One of the things we use a lot of in computer science is logic rules. And one of the biggest logic rule or logic laws is DeMorgans Law. It allows us to rewrite sentences, simplify things, statements, and make things a little bit easier for us to deal with when we're programming. So these are the two DeMorgans laws, these two right here. The first one that says it is not the case of A or B is the same as, or logically equivalent, the equal signs, not A and not B. And then similarly, not A and B is equal to not A or not B. Now, if you take this with with McDonald's and Burger King here, sometime maybe logically it would make more sense to you. So it is not the case, so or I am not going to take you to McDonald's or Burger King. So logically that says to you, okay, I am not going to take you to McDonald's or Burger King. That means that I am not going to take you to McDonald's and I am not going to take you to Burger King. I'm not taking you to either of them. Okay, I'm not taking, okay? Let's say okay one more time. So down here, this one says it is not the case that I'm taking you to McDonald's and Burger King is equal to. So to me, that sounds like I'm not going to take you to McDonald's or I am not going to take you to Burger King. Okay, so I could take you to one of them. I'm just not going to take you to both of them. I don't know if that maybe makes sense. But what this says is that these are logically equivalent. So logically equivalent means no matter what values I pick for A and B, A is true, B is false, whatever, or A and B are both true, it does not matter. Whatever I pick for A and B, both of these are going to give the exact same truth value. So if say I pick truth for whatever, I'll explain it down here. Sorry for the mess. Okay. So in order to show you this, we're going to do this truth table. Now this is a ginormous truth table, but this is how truth tables have always been created. We create all the different possible scenarios. So in this particular one up here, I have A's, not A's. I have A or B. I have not A and not B. Like I have all these different pieces. So what we do in truth tables is just break up those little pieces and do each one of them singly. So I've done the true false, the A and B part, but then we have to do each one of these. So this is a nice review of A and B. So remember, and is only true when they're both true. So the rest of these are going to be false. Okay? A or B is true all the time except when they're both false. When they're both false, it's false. The rest of the time, it's true. Then this is not A. So remember, it's not A because we're going to be using it in places like that. So this is A. So not A would be just the opposite of it. So the first one's false, so this one would be true, true, false, false. Now this is B, so I'm looking here at B. B is false, so here it would be true, and then it's true, so it would be false. So it's just the opposite of them. Okay, so now we're doing not A and B. So A and B is right here, so I'm just changing that order. So you can see the logic of these logical truth tables, that they just do one step at a time. So not A and B, so I'm just doing the opposite of this right here. So that is true, 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 false. And then not A or B, so here's A or B. So I'm doing the opposite of that. So you don't have to do too much at the same time. Just hoping like I'm not screwing up as I go. Okay, so not A and not B, so I'm doing an and between these two. So remember, an and is only true when they're both true, so the top one's the only one that would be that. Now you see what just happened here? these two have the exact same truth value. So that means whatever I pick for A and B, their truth value is going to be exactly the same regardless. So yeah, so not A or B is the same as not A and not B. And then this last one, not A or B. So now I'm putting an or between these two. So remember, an or is false only when they're both false. So this one's false, the rest are true. So now these two have the same truth value. So not A and B is the same as not A or not B. And that is DeMorgans Law. That proves it. I just proved DeMorgans Laws to you. That's right. Bam. So it's almost like the distributive property of multiplication, just to help you remember how it works. You basically take the not and you multiply, or you distribute it in to all three pieces. So you take the opposite of A, the opposite of and is or, and the opposite of B is not B. Okay. The opposite of A here would be not A. The opposite of or would be and the opposite of B would be not B, because it's true or false, so not true, whatever. Okay, and that's all we have to do here to figure out which ones are equivalent. So I just distribute this in to all three. Not A is just A. Not changing or around becomes and the opposite of B is not B. So this would be A and not B, which is choice 1. Okay, and this one, multiplying it in. Or I say multiply, but you know I don't mean it. I mean, just throw that not in there. Okay, not A is just A. And becomes an or, and not B becomes B. So it's A or B, or this one. All right, I hope you understand DeMorgans Law and you're able to use it, at least in the simplest sense. Have a nice day.